Hello everyone. Today's topic of discussion is data sufficiency, and in today's video we will be going through a couple of questions of inequalities from data sufficiency part, right? So we will be taking up around 5 questions in this video. So these questions are, you can say, are on a moderate level, but they will actually clear up a lot of concepts as far as the inequality part is concerned, right? Now what we will be doing is what actually you will be doing is, as soon as I show you a question on a screen, you will pause the video, you will attempt the question yourself first, so that you'll have a better understanding of where you were lacking and how you're supposed to solve a particular question. Correct? Okay, then let's begin without wasting our time any further. Okay. This is question number one. Pause the video and try this question yourself first. We are already done with the basics of mod, the basics of how do you read mod with inequality. If you're watching this video for the first time, if you do not know how do you solve mods with inequalities and all those things, then you can go to the playlist of binges education ACT plus GRE plus GMAT and go to the modulus section and watch the videos of modulus. You'll have a very good understanding of how to attempt questions like these. If you have, then please go ahead and try this question. All right, let's see how we can solve this one. So the question is x greater than 0? Statement number 1 is mod of x plus 3 is less than 4. Second is mod of x minus 3 is less than 4. So is x greater than 0? So my first statement is mod of x plus 3 is less than 4. Now while we were discussing mod, I told you that whenever you have a positive sign in between, the positive sign does not stand for distance. The negative does stand for distance, but the positive sign does not stand for distance. So we will be rewriting this as modulus of x minus of minus 3 is less than 4. So distance between x and negative 3 is less than 4. Distance between x and negative 3 is less than 4. So let's draw this on a number line. So we have negative 3. Now we need the distance to be less than 4. First let's mark out the points which are at a distance of 4. So one of them will be 1, another will be like minus 7. Now since we need a distance less than 4, so we will ensure that we will stick to the right of minus 7 and to the left of 1. So the question is x greater than 0? So yes, because 0 will be slightly on the left of 1. So x can be greater than 0, x can be equal to 0 also, and x can be less than 0 also. So do we have a definite conclusion from statement 1? Do we have a definite conclusion? No, we don't have. So let's write D, A, B, C, E. So A goes out, which means D also goes out. Now, the second statement, mod of x minus 3 is less than 4. Now, since there is a negative sign, so it will stand for distance. Now, this means distance between x and 3 is less than 4. Distance between x and 3 is less than 4. So we'll put 3 here. Look out for the numbers which are at a distance of 4 first. So you will have 7 and you will have negative 1. Now you want a distance to be less than 4, so you'll ensure that you are to the right of minus 1 and to the left of 7. Now the question is x greater than 0? Now 0 will be slightly on the right of minus 1. So yes, x can be less than 0, x can be greater than 0 also, x can be 0 also. All of them satisfies. So do you have a conclusive answer to the question is x greater than 0? The answer is no, you don't have, which means B is out. Now, if we combine both of them, let's see what's the common part. So let's draw both of them on a number line. So this is minus 3 This is minus 7. This is 1, and this is the part to be taken into consideration. Okay. For the second one, we have 3, we have minus 1, and we have 7. So this is the part to be taken into consideration. So you can very well see that the common part for both of them is when x is between minus 1 and 1. Now if the value of x is between minus 1 and 1, do we have a conclusive answer of x greater than 0? Now in this case x can be negative, x can be equal to 0 also, and x can be positive also. Hence our answer is option number E, because C is also out. Like by using both these statements together, we can't still find out whether x is greater than 0 or not. We're done with the question. This is a typically easy question if you know like how to read a linear modulus with inequality. It's a typically easy question. All right, let's move on to the second question now, guys. Pause the video and try this question, please. All right, let's see what we can do with this one. X and n are integers. What type of integers is not given to us? X can be positive, n can be positive, x can be negative, n can be negative. Both of them can be 0 also. Is the sum of x and n less than 0? So the question is x plus n less than 0? This is the question asked. Is x plus n less than 0? Now let's see what statement 1 has to say. So statement 1 says x plus 3 is less than n minus 1, or you can say that x plus 4 is less than n. So do I have any conclusion regarding whether x plus n is less than 0 or no? I don't know anything about x and n apart from the fact that they are integers. For example, let's suppose if I say that x is equal to 0, so in that case n will be greater than 4. Greater than 4, it can be 5, it can be 6, it can be 7, it can be any number. I can say x is equal to minus 20. In that case, n is greater than minus 16. So n can be minus 15, n can be minus 14, n can be 100 also, n can be 200 also. So do we have a specific conclusion? No, we don't have, because we do not know the values of either of the two. It simply says that x and n are integers. That does not stand for the fact that either of them is positive or negative, or the values. We have nothing. We just have a simple relationship from statement 1 that x plus 4 is less than n. Do we have x? No. Do we have n? No. So if we write D, A, B, C, E, A goes, D goes. That is statement 1 alone is not sufficient, which means both the statement individually are not sufficient. So A goes, D goes. Okay, statement number 2. Minus 2x is greater than 2n. So let's do one thing. Let's add 2x on both the sides. So I'm going to have minus 2x plus 2x is greater than 2n plus 2x. So 0 is greater than 2n plus 2x. So we will have n plus x is less than 0. I think this is what we were trying to figure out, right? So it's like basically like how do you interpret and how do you understand a question? Take a couple of seconds, read the question carefully, like what operation am I supposed to use in this question, and then move on forward, right? So when I saw that minus 2x is greater than 2n, so the first thought that came in my mind is that I need both x and n on the same sides of inequality. On the same side of inequality. That's exactly what came in my mind. So I simply added 2x on both these sides. Okay. So I simply got n plus x is less than 0. So this is basically what was asked in the question, is x plus n less than 0? So we are getting an affirmative answer. I'm sorry, we are getting a conclusive answer, which is basically yes. Hence Statement 2 alone is sufficient, which means our answer in this case is simply option number B, and that's it. Okay. Let's move on. Pause the video and draw this question, please. Okay. So the question is A greater than C? Now the first statement says that B is greater than D. Now I don't think B greater than D is going to have any correlation with whether A is greater than C or not. So simply saying B is greater than D will definitely not give me any answer, because A and C are like different values, B and D are like different values, different variables, different numbers, so no correlation. So if I do D, A, B, C, E, so A goes out, D goes out. Okay. What's the second statement? Second statement is that AB square minus B is greater than B square C minus D. Let's add B on both the sides and let's subtract B square C on both the sides. The reason why I'm doing this is because I have actually realized that I have a B square here and I have a B square here also. So I want AB square and B square C to be on the same sides of inequality. That's the logic which I'm using. So I'm gonna have AB square minus B squared C is greater than B minus D. I have added B on both the sides and I have subtracted B squared C on both the sides. So this becomes B square A minus C is greater than B minus D. Now the interesting part is the question is A greater than C? Do we know B? No. Do we know relationship between B and D? No. Just using the second statement, no, we don't know that. Do we know B square? No. We just know that B square into A minus C is greater than B minus D. It may happen that, for example, B minus D is 8, A minus C is 1, and B is 3, which means B square is 9. Right? So there are like a lot of possibilities which can happen. So do I have a conclusive answer using statement 2? No, I don't have any conclusive answers using the statement 2 alone. So that means B also goes out. Now let's combine the two statements. The first statement says that B is greater than D, which means can I draw a conclusion from here that B minus D will be greater than 0? Which means basically what I have done is I have subtracted D on both the sides. So if B is greater than D, then that means B minus D will be greater than 0. B minus D greater than 0 basically means B minus D is a positive value. B minus D is a positive value, which means this number here is a positive number. Now, if B minus D is positive, if B minus D is positive, can I say since B square into A minus C, since B square into A minus C is greater than B minus D, B minus D being positive, can I say this number also has to be positive? Can I say B square into A minus C has to be positive? It can't be 0, it can't be negative. Because B square into A minus C is greater than B minus D. B minus D is already positive. So B square into A minus C is also positive. Which means we can say B square into A minus C is greater than 0 because it's positive. Now let's talk about B square. No matter what the value of B is, no matter what the value of B is, can I say B square will always be 0 or positive? Because square of a number can never be negative, right? Whether the number is positive or negative, square will either be 0 or positive. Now, can b square be 0? Can b square be 0? No, b square cannot be 0, because if b square is 0, then 0 multiplied by anything will always give you what? It will always give you 0. However, in this case, b square into a minus c is greater than 0. It is greater than 0. That means b square has to be positive. So if b square is positive, the product is positive, product of b square and a minus c, and that means a minus c also has to be positive, which means a minus c is greater than 0, which means a is greater than c. This is exactly what we were looking forward to have a conclusive relationship between a and c. We were not looking forward to that a should be greater than c. That's not the point. The point is we need a conclusive relationship between a and c so that we can answer the question. The question is A greater than C? So in this case, yes, it's coming out to be greater. We could have got the answer the other way around also. Probably we could have got the conclusion as A is less than C. Again, that's a conclusive answer. Because you can say that no, A is not greater than C. Okay. So anyways, in this case, the answer is option number C. But this is like an interesting question. Not too difficult, but yeah, it does require somewhat thought process and somewhat understanding, a good understanding of inequalities. All right, let's move on to the next question. So pause the video and draw the question, please, guys. All right, let's see what we can do with this one. So it says that 6xy is equal to x square y plus 9y, and we need to find out the value of x into y. Okay, now the first thing, before I even go through option number one and option number two, the first thing that will actually come in my mind is let's do one thing. Let's bring all of them on the one side of equality. So let's subtract 6xy on both sides, and I will get x square y minus 6xy plus 9y is 0. Because the reason is that when I read this equation, I realized that I have y in each one of them. So that means I can take y common when I'm going to bring all of them on the one side. Okay, so I'm going to take y common, and this becomes x square minus 6x plus 9, and this is equal to 0. So y, then I'm going to do the middle term splitting, although it's not required if you are good with math part, because you'll realize that this expression here is nothing but x minus 3 square. But if in case you're doing math after a long period of time, so it's fine, you can do the middle term splitting. So this is what your equation will be. Okay. And before we move on, a question here, probably it will pop up in minds of some of you, that why did I not cancelled y here? Like, you have y on both the sides of both the sides of equality. It's not an inequality also. So equality is usually simple to understand. Why did I not divide by y on both the sides, or effectively why did I not cancelled y on both the sides of inequality? Do let me know your answers in the comment box. I'll be waiting for those comments. Okay. All right. Okay, let's move on with the calculation now. So y into x minus 3 square is 0. So y into x minus 3 square is 0. So what all conclusions can we have? We can have y equal to 0. X can be anything. We can have x minus 3 as 0, which means x is equal to 3, and y can be anything. And at the same point of time, we can have y equal to 0 and x can be 3. So all three are possible. All three are possible. Okay. So question is, what is the value of x into y Okay, so now I haven't read these statements yet. So the first possibility is y 0x is anything. So in that case, I can simply say x into y will be 0. In the third case, y is 0, x is equal to 3. In this case, x into y will again be 0. Why do I need statements then? I'm getting x into y as 0. The point is with the second conclusion that I have. X is 3, y can be anything, and anything does not mean 0 always. Which means in this case, my product can be 3y, it can be 0 also. It will be 3y or it will be 0 also. So if you miss out on any of the three cases, then you will actually be thinking, okay, why do I need statements in this question? I'm getting my answer as 0. Do I actually need it? Okay. All right. So the first statement is, now we just need to figure out using the two statements that whether it is statement 1 or 3, because in that case it's always 0, and if it is statement 2, then in statement 2, then what's the value of y? Okay, that's basically what we are trying to figure out. Okay, so first statement says that y minus x is equal to 3, or you can say that y is equal to x plus 3. So y is 3 greater than x. Now if y is 3 greater than x, then it will definitely not go with statement 3. It will definitely not go with statement 3. It can go with statement 1, because when y is 0, x can be anything, so x can be 3. It can definitely go. And it can go with second statement also. That is, if x is equal to 3, in that case y can be 0. So from both these statements, that is statement 1 and statement 2, we are getting x as 3 and y as 0. From both these statements, we are getting x as 3. From both 1 and 2, the only possibility is, okay, I think I've messed up somewhere. Let me just, so it's y which is equal to x plus 3. So y is equal to x plus 3. So if I take the first statement into consideration where y is equal to 0, in that case x has to be minus 3. But still the product is 0. In the second statement that I have, I need to have x as 3. I need to have x as 3, and in that case y will actually become 6. So I think I have said the other way around, so I'll apologize for that. From the first statement says that y is 0, x can be anything. So you will put y as 0, you'll get x as minus 3. Second statement says that x is equal to 3, y can be anything. So when x is equal to 3, y is actually equal to 16. So you're not getting 0 in both the cases. I apologize for the mistake. So when y is 0, x is equal to minus 3, product is 0. And in this case, the product is 18. So do I have a conclusive answer from statement 1? No, I don't have. So D, A, B, C, E, D goes, A goes. Because statement 1 alone is not sufficient. Let's see what statement 2 has to say. So statement 2 says that x cube is less than 0. Now what conclusion can you actually draw from x cube less than 0? If x cube is less than 0, can I say one thing for sure, that x has to be negative? Can I say x has to be negative? Now, very, very, very interesting conclusion. If x is negative, I can't use statement 3, because in this case, x is 3, which is positive, and I can't use statement 2 also, because again, x is 3, x is again positive. I can't use 1, I can't use 2, I can't use 3. So the only possibility that I can have is statement. Let x be anything, but y is 0. X is negative, but y is 0. Hence the product is 0. Hence the product is 0. Interesting statement number 2. So your answer is simply option number B. So just be careful with your calculations and don't miss out on any of the cases, please. Okay, and do let me know why did I not cancel y on both the sides of equality. All right, let's move on to the last question of the video. Pause the video and draw this question, please, guys. All right, let's see how we can solve this one. So it says that is a by b less than 0. So how can we make a by b actually less than 0? That is, if we want to make a by b negative. So we can do a negative, b positive, or we can do b negative and a positive. These are like the two ways in which we can do this. Okay, but the question is it less than 0? So if in case from either of the statements you get a by b to be greater than 0, then also you have a conclusive answer, right? So you're actually looking for a conclusive answer, not an affirmative answer. Anyways, let's move on with statement number 1. So one says that a square divided by b cube is less than 0. Now think, when would be a square by b cube less than 0? Now if we talk about a square, again it's a square quantity. Is it possible for a square quantity to be negative? Is it possible for a square quantity to be negative? The answer is simply no. Square quantity is either 0 or square quantity is either positive. Now can a square be 0? No. Because if a square was 0, then 0 divided by something would be 0. 0 divided by b cube, how can it be less than 0? This is not possible, right? 0 divided by b cube will be 0. Or if in case b also becomes 0, then it will become not defined in maths, right? So the only possibility as far as a square is concerned is that we can have a square to be positive. Now if a square is positive, what you are doing is you have a positive number, you are dividing it by b cube, and this is less than 0, which means this is a negative number. Positive number divided by b cube is negative. That will only happen if b cube itself is negative. Now if b cube is less than 0, then b is also less than 0. That's the only way of making b cube less than 0. There is actually no other way out. So if b cube is negative, then b has to be negative. Now the interesting part here which we need to understand is, if b is less than 0, okay, that's fine, but what about a? A is not positive. I'll repeat myself again. What I said was a square is positive. The numerator is positive. I never said a is positive. I never said a is positive. I said a square is positive. Now if a square is positive, then that means a can be a positive number, because square of a positive is still positive, and a can be a negative number also, because square of a negative is also positive. Minus 3 square is 9, minus 4 square is 16, minus 5 square is 25. So do we know anything about a? No. Do we have a conclusive answer? Let's see. If a is positive, then it will be positive by negative, which will actually result into a negative quantity. But if a is negative, then it will be negative divided by negative, which means it will be a positive. So is a by b less than 0? Don't know. A by b can be less than 0, a by b can be greater than 0 also. So do we have a conclusive answer from statement 1? No, we don't have. A goes, D goes. Let's go through statement number 2. A b to the power 4 is less than 0. Now let's first solve b to the power 4. Again, you have an even power. Again, you have an even power. So b to the power 4 can be 0, or b to the power 4 can be positive. Now again, b to the power 4 can't be 0. Because if b to the power 4 was 0, then a multiplied by 0 cannot be negative, which means b to the power 4 has to be positive. So a multiplied by a positive quantity is less than 0, which means it's a negative number. When can that happen? Only in one case, that is when a will become negative. That is when a will become negative. So from the second statement, one thing is sure, that a is negative, but what about b? Now again the same thing, b to the power 4 is positive. That does not mean if b to the power 4 is positive, that does not mean that b will be positive, because b can be negative also. Minus 2 to the power 4 is 16. Minus 3 to the power 4 is 81. Minus 4 to the power 4 is 256. So b can be positive, b can be negative also. So again, you will have the two conclusion. So if a is negative, so you will have negative by positive, which is negative. Or you can have negative by negative, which is positive. Now, if we combine both the statement, because statement B alone is also giving you like two conclusions, so B can't be the answer. If we combine both the statement, in that case, A has to be negative and B also has to be negative. Or if you'll observe, you'll see that this is the only conclusion which is coming out to be same or similar. That is A and B are both negative. So negative by negative is positive, which means if we combine both the statements, we can definitely conclude that A by B is greater than 0. This is our definite conclusion. So if A by B is greater than 0, is A by B less than 0? The answer is no. A by B is not less than 0. Is no a conclusive answer? Yes, no is a conclusive answer. Hence our answer is simply option number C. Alright guys, so these were the 5 questions based on inequalities. I hope you have learned something. I hope you have enjoyed the video. So thank you so much for all your support, and don't forget to subscribe the channel for more videos and exam related content on GMAT. Okay. If you have any questions, if you have any queries, please feel free to ask that in the comment box, and do follow us on our Facebook page. Do share the videos with your friends also. And if you're looking for personalized classes, you can always connect with us. You can send us a mail, or you can also drop us a WhatsApp. Thank you guys. Keep watching and keep learning. Thank you so much.